Today our topic is entropy and second law of thermodynamics. The formula of entropy is equal to heat change reversible divided by time when the reaction is taking place in a reversible way. So if we talk about the infinite entropy change, infinitesimal changes, so it means that small changes are taking place. It's shown in the form of the del s, and when we talk about the finite changes, bigger changes, then it is represented by the delta s. So as f is a state function, it is not depending upon the path in which the process is taking place, so the reaction can be shown in this form. So this equation applies to a cyclic process where the reversible process is taking place. If the cyclic process is said to be changing from a to b and then b to a, then we can write this equation or change in the entropy in this sum up form. And if we take the change of the entropy from b to a to the other side, it becomes negative factor. This equation shows that the entropy change from a to b and b to a in the cyclic process of a reversible reaction is always equal but opposite in direction. The negative sign shows the opposite in direction. So but we know that in the second law of thermodynamics, we are concerned about the irreversible process, not about the reverse process. So we should talk or concerned about the irreversible process. For this, let's study to the Clausius in 1854. He extended the entropy equation to the cycles that are containing the irreversible steps in the cyclic processes. Clausius inequality is basically the mathematical statement of the second law of thermodynamics. There are some assumptions that are given by the Clausius. Number one is that if any part of the cyclic process is irreversible, the inequality applies. Means that in the symbol, inequality symbol will be used rather than the equal symbol in the equation of the entropy. So if the cyclic process is not irreversible, means that if it is reversible, then equality symbol is used in this form. Means that when the cyclic process is reversible, then equality symbol is used, and if the cyclic process is irreversible, then the inequality sign is used. Third point is that it is impossible for a cyclic integral to be greater than 0. What is a cyclic integral? Cyclic integral is the heat change divided by the temperature. Cyclic integral is the heat change, mean del q over t is also called the cyclic integral, and it is impossible to be the cyclic integral to be greater than 0. It is always lesser than the 0 when the process is reversible. The temperature of the system will be equal to the temperature of the surrounding in that case. So the equation appear in this form. With the help of this equation, when we are talking about a reaction is taking place that is not in the cyclic form, non-cyclic, so the inequality appear in this form. So we have talked about this line, and let's come to the two basic gains that we are having from the thermodynamic relation with the entropy. The number one is that there is a state function called entropy, so as that can be calculated by using the equality equation. So if we want to determine the change in entropy, then we use the inequality equation, and if we want to determine the state function of the entropy, then we use the equality equation. Clausius inequality expression is a fundamental requirement for the real transformation. The inequality of the equation enhances to decide or enable us to decide whether or not some proposed transformations will occur. What does the transformation mean here? Transformation simply means here the conversion of the reactants into the product form. So if we say that there is a second law of thermodynamics that can be stated well in this form: entropy increase in a spontaneous process is in an isolated system, because for the isolated system the del q means that the heat change is 0, so therefore the entropy keep on changes. It means that entropy of an isolated system will keep on increasing up to the spontaneous process is taking place. And if the spontaneous process taking place probability is decreased or stopped, it means that at that point entropy has reached to its maximum point. No more the spontaneous process process will take place means that entropy is already reached to its maximum point. Thus the entropy change tell us whether a process or chemical change or reaction can occur spontaneously or in an isolated system or not. And when we talk about a system that is not an isolated system, so in that scenario we will take in consideration the system as well as the surrounding. In that case we will say that the total entropy will be equal to the entropy of the system plus entropy of the surrounding. First, consider a reversible process. In the reversible process, entropy change in system minus del Q reversible divided by T reversible. Why the minus is used? Minus sign is showing here because when a process is taking place, system is gaining the heat, and surrounding is the point. So surrounding is the point from where it is gaining, means that surrounding is losing the heat and the system is gaining. In the sense, surrounding is getting negative charge because its heat is getting lost. So the entropy of the system minus entropy of the surrounding is equal to 0. Because this 0, why we are using here 0 sign? Because as a result, as a submission, it becomes negative because the amount of the heat taken from the surrounding is equal to the amount of the heat absorbed by the system. It means overall change remains 0. So when the reversible process is an isolated system, the equation appear in this form where the entropy change is equal to the del Q reversible over surrounding is equal to the reversible, means that the entropy of the surrounding, entropy of the system. So since for the reversible process the temperature of the system is equal to the temperature of the surrounding, that we have already studied in the previous page. So the second, consider that was all about the consideration of the process in which the reversible process is taking place. But when we talk about the irreversible process, in which we are saying that the total entropy is equal to the entropy of the system plus entropy of the surrounding. In that sense, if we want to take out the entropy of the system, then it become equal to the ds, mean that total entropy minus entropy of the surrounding. When we talk about the irreversible process, in which the entropy change of the system is equal to the entropy change from the minus entropy change of the surrounding. So if the transfer of the heat occurs reversibly in the surrounding, then entropy change can be represented in this form where the negative sign shows the removal of the heat from the surrounding. So simply the entropy change of the system is greater than the entropy change of the surrounding. Why the entropy change in the system is greater than this entropy change? Reason is that because the process is taking place or the reaction is taking place in the system, so the heat is being absorbed from the surrounding into the system. In this way, more the heat is absorbed, more the changes in the structure are taking place in the from the system, so more is the entropy of the system as compared to entropy of the surrounding. Taking into consideration in this equation where we have said this for the finite change. For the finite change means the bigger change, in that way we are writing the delta S that is bigger than the entropy change in the surrounding. So let's talk about the conclusion. Conclusion is that for the spontaneous and where the one of the path is irreversible, for that case inequality symbol is used for the equation of the entropy. And for the reversible process where no spontaneity or where no irreversible process is taking place and there is no spontaneity, in that case we will use the equal symbol in the equation. And it is impossible for equal entropy change where the entropy of the surrounding become greater than the entropy of the system. So for a finite change of the possibilities are these, that the spontaneous and irreversible process where this is phenomena is taking place, in that case the delta S means the bigger change in entropy is greater than the 0 if the spontaneous and irreversible process is taking place. If the process is reversible, in that case the entropy change is equal to 0. And if the this is scenario where the entropy change is lesser than the 0, this is impossible. That was all about the relation between the second law of thermodynamics and entropy.